Hi dear students, here Dr. Anil Darekar. Today we are going to discuss Advanced Engineering Materials, Unit number 3 from Engineering Chemistry. So first we will discuss some important terms and types of polymer. So what is meant by polymers? So poly means many and mer means monomer molecules. So the substance having high molecular weight and made by joining large number of simple molecules means by joining of large number of simple molecules with one another we get a long distance chain, and that long distance chain is known as a polymer. And if we connect large number of simple molecules, the produced long polymer chain with high molecular weight. Okay, so the substance having high molecular weight and it is made by joining of large number of simple molecules. Now example, polythene, or you can say polyethylene. So polyethylene is made by using ethene as a monomer molecules. So ethene monomer molecules join together and we get a polyethene. Now second important term, monomers. Now monomers means what? Monomer is a simple chemical unit or simple chemical substance. You can say it is a small unit. If unit is a small, then its molecular weight is a low, and that simple chemical substance, small chemical compound, molecule, you can connect with one another, and by connecting with one another we get a long chain polymer. So simple chemical substance of a low molecular weight which can be converted into polymer. Okay, so what is the condition? Then that molecules acting as a monomer. So monomer molecules has at least two reactive sites. Monomer molecules has at least two reactive sites, or you can say positions. So by using that two reactive sites or positions, that monomer molecule can link with one another. So reactive positions may be in the form of multiple bonds or functional groups. Let us see the examples of monomer molecules. First one is ethene. So double bond is there, and one double bond produces two reactive positions. How? Because in double bond, one bond is a sigma bond and another bond is a pi bond. So pi bond break symmetrically and each carbon get one electron. So one electron, that is what the free radical, and free radical is active. So one double bond produces two reactive sites. Second example is propylene, and in propylene again double bond is there, so it produces two reactive sites. Third one, 1,3-butadiene. So in 1,3-butadiene again pi bonds are there, right? Two double bonds are there, so it produces reactive sites. Then phenyl chloride. In phenyl chloride also we get a free radical after breaking of a pi bond. Then ethylene glycol. In ethylene glycol you see two OH groups are there, as we seen that we required at least two OH group. Then adipic acid. In adipic acid, two acids molecules are there, groups are there in the molecule. Now third important term, polymerization. So what is meant by polymerization? Actually polymerization is a process, is a chemical process in which what happen? Monomer molecules join or link with one another and it produces polymer molecules. So here you can say polymerization is a chemical process. Process of what? Process of formation of polymer molecules. Right? And how polymer molecules produced? Polymer molecules produced by joining of large number of monomer molecules. So here we can say that the process of conversion of monomer molecules into polymer molecules is known as polymerization. You can see the example. Styrene on polymerization, they produces polystyrene. So styrene changes to polystyrene. Then next one is a functionality of monomers. Functionality means what? The number of reactive positions or groups, or you can say sites, present in the molecule of monomer. So number of reactive positions or groups or sites present in the molecule of monomer. That is called as what? Functionality of monomer. So in functionality of monomer, monomer may be bifunctional, trifunctional, tetrafunctional, polyfunctional. So in bifunctional, simply two groups are there. They can form a long chain compound. So bifunctional means two reactive position, trifunctional means three reactive position, and tetrafunctional means four reactive positions. So example, bifunctional 2 OH group, trifunctional 3 OH group, and tetrafunctional 4 OH group. So 2 OH group with 2 carbon, it is a ethylene glycol. Then 3 OH group with 3 carbon, it is a glycerol. Then 4 OH group with 4 carbon, it is a sorbitol. So here we seen 4 important terms. Now we will see the difference between two types of polymer. So in that, first type is thermo-softening polymer and second type is a thermo-setting polymer. So what is meant by thermo-softening polymer and what is meant by thermo-setting polymer, that we are going to see. So thermo-softening polymer is formed by addition reaction, or you can say chain polymerization reaction. And here thermosetting is formed by condensation, or you can say step growth polymerization. So simply you keep in mind, thermosoftening is an addition type of polymer and thermosetting is a condensation type of polymer. Now thermosoftening is characterized by linear structure. So addition reaction produces linear structure and condensation reaction produces a 3D structure. So setting is a 3D and softening is linear. Then thermosoftening polymer required only bifunctional monomers, and that bifunctional monomers, that functionality is multiple bond. And in thermosetting polymer, monomer molecules are polyfunctional, and polyfunctional is functional groups. For example, OH group, an example is a sorbitol. Here in thermosetting we get a 3D structure. So 3D structure required polyfunctional monomer. And here in thermosoftening we get a linear structure. And when we get linear structure, if monomer molecules are bifunctional, then thermosoftening polymer becomes soft on heating and hard on cooling. This is what the actual definition of thermosoftening polymer. So thermosoftening polymer becomes soft on heating and hard on cooling. And thermosetting polymer, there is no effect on heating and cooling. Once formed, no change. If we apply more temperature, it will decompose, but it will not become soft on heating. So thermosoftening, soft on heating and hard on cooling. And thermosetting, once formed, no change. Then thermosoftening type of polymer having a low molecular weight and setting type having a high molecular weight. So softening, low molecular weight, and setting, high molecular weight. Then thermosoftening polymer soluble in organic solvent and setting insoluble in organic solvent. So softening, soluble in organic solvent, and setting insoluble in organic solvent. Soluble, insoluble. Then thermosetting, waste can be reused, as we seen that on heating it becomes soft and on cooling it becomes hard. So waste can be reused. Thermosetting, waste cannot be reused because in definition we seen once form, no change on heating and cooling. So waste cannot be reused. Then thermosoftening is a soft and weak, and thermosetting is a hard and strong. Why it is a hard and strong? Because monomers are polyfunctional and polymer is a 3D. So 3D form is a hard and strong, and thermosoftening is a soft and weak. And last point, thermosoftening polymer reshaping can take place. Means you can change the shape of the material again and again, as we know that softening type of polymer becomes soft on heating and hard on cooling. That's why we can do reshaping. And thermosetting, we can't do reshaping because once form, no reshaping. Why? Because no effect on heating and no effect on cooling. So this is what the difference between thermosoftening and thermosetting along with the important terms. And in next session we will see specialty polymers, and in specialty polymers we will see properties, applications and preparation of that polymer. Thank you. Thank you for watching.